Hello everyone, today we're on lesson 5.5 and it is on page 211 in your colored math book. We're going to learn about prime and composite numbers. The question we're going to answer is, how can you tell whether a number is prime or composite? Alright, let's start off with the first question. I already did a little work as you can see on this page, just for time's sake. The question says, students are arranging square tables to make one large rectangular table. If the students want to choose from the greatest number of ways to arrange the tables, should they use 12 or 13 square tables? All right, and what we did was, or what I did, they started the first one for me. They did 1 times 12. If you put one table all the way across in a row, 12 tables all the way across, how many tables would you have? 12. So that was the first way they did it right here. Then I drew 2 tables in a row of 6. So 2 all the way down 6 times. So that was 2 times 6. So they used all 12 of their tables this way. The next way I did it was I did 3 down and 4 across. 3 down and 4 across was the way I did it here, and that was all 12 of their tables again. So they want us to draw all the possible arrangements of the 12 tables and 13 tables. So I did that same thing with 13, but the only way I could figure out to do with the 13 was do one straight line across. Put all 13 tables in one straight line. All right, and one other thing they want to tell us is some factors in a different order should be counted only once. For example, 3 times 4 and 4 times 3 are the same factor pair. So I could do this, but I could make it 4 down and 3 across, but it would be the same factor pair. So I don't need to draw both of them. So I've drawn all my possible ways. I drew 2 times 6 and 3 times 4, and they already had the 1 times 12. Those were the ways for the 12 tables. The 13 tables, the only way I could draw that was the 1 times 3. So there are more ways to arrange 12 tables than 13 tables, because we have 1 way, we have 2 ways, and we have 3 ways. 13, you only have this 1 way that we could have arranged it. Here it talks about the prime and composite numbers. A prime number is a whole number greater than 1 that has exactly 2 factors, 1 and itself. So 1 in itself is the only factors it has. Composite numbers are a whole number greater than 1 that has more than 2 factors. Factors of 12. We just did that on this page back here. So it would be 1, 2, we're putting them in order, 3, 4, 6, and 12. Let's see if we're right. 1, 2, 3, 4, 6, and 12. Check back again. 1, 2, 3, 4, 6, 12. Next, the factors of 13. We only could do it one way, right? We want to go from the least to the greatest, so it would be 1 and 13. 1 and 13. So the factors of 13 are 1 and 13. The factors of 12 are 1, 2, 3, 4, 6, and 12. 12 is a blank number. 13 is a blank number. They want to know, is it a prime or a composite number? Let's look back at the prime and composite. Prime number is a whole number greater than 1 that has exactly two factors, 1 and itself. So what only has two numbers? Which one of these? And it can only have 1 and itself. So it would be 13. Composite numbers is a whole number greater than 1 that has more than two factors. This has 1, 2, 3, 4, 5, 6 factors. So 12 must be a composite. I hope you're writing it neater than me. All right, so that explains prime and composite numbers. We will work on it more in class. If you have any questions, let me know. Bye, everyone.